Hello, everyone. I'm back at doing this. I'm gonna try to do it daily, even though I skipped yesterday. uh, what's this fire thing? Does that mean I lost my streak? Oh, did I do Duolingo? I think I did. Can't lose my Duolingo streak. I did not. Okay, I'll do it really quickly. Yeah, so I'm back to doing this. I just love, I'm actually pretty into it. This isn't bad. It's pretty fun, actually. I wouldn't be doing it if it wasn't fun. What is happening? I guess there's daily questions. Maybe I'll do that some other time. But still on the, nope, that's not, yeah, that way. Still on this. I have to complete this question. I think I'm going to complete a page a day. That should be my goal. So I'm going to complete this page today. So 101 to 225. So I guess I'm not sleeping until this happens. Let me open up Spotify. I'm going to need music for this. So yeah, I did the math. If there's 18 pages and you do one per day, that's 18 days. I think that's pretty good. I'm pretty excited. Okay, I realized that I'm not doing this. That's too much work. What I'm going to do instead is change it to an integer and then add it and then go back to a string. I think that's a lot easier. I is less than a dot length I plus plus, and then if int sum a int sum b int multiplier equal 1, and then I constantly multiplier times equal 2 because that's binary, right? And then for every a you keep adding. So if a I guess I have to do this the other way. If I is greater than is equal to 1, then sum plus equal multiplier, else I guess you don't do anything. Character 1. Alright, and we do this for B2. Yeah. And the multiplier is equal to 1. Alright, so after that we just do A plus B. It's the total sum. This is way easier than what I was doing before. Why didn't I do this earlier? Equal sum A plus sum B. So now we have the decimal representation of that. Why is the tab so weird on this? Is this all tabbed wrong? Then we do 4 if I equals 0, I less than total sum I plus plus. And we can just write a simple turn this into a character. So we can, you know, we take our multiplier, it's equal to 1, and then we do the remainder. So if is it remainder or okay, so let's do 65 for example. Remainder 1 is equal to 0. No, it's not remainder. You divide one, 2, 3, 4, 8, 16. So if I had to represent 70, that would be 64 plus I guess this would be a while loop because we don't know how much, but 64 plus 4 plus 2. How do we get that though? it would be remainder, right? So 70 remainder 2 is equal to 0. No, it's not remainder. How do we get this? Okay, we take 70. I think we have to minus by the next number. Huh. How do people usually do decimals binary? Is this cheating? I'm gonna say it's cheating. I have to solve it myself. The way I always do is manually. I just take this and I know like the biggest number below it. But that's obviously I can't do that in code. How else would you know this is 64 and 4 and 2? Wait, maybe I can just represent C++. I mean, the decimal number is represented binary. Decimal to binary. Okay. Bit set has a .to string. Hey, that's exactly what I need. Return total sum. 128. I wonder if that works. I need this. Yes, work me wrong. Multiplier. I guess I don't need that. I don't think it's as simple as doing this. Also, that's not correct. I think I'm gonna have to construct it myself. No cheating for me. Zero. What? I don't even think this is working. Sum A plus equal multiplier. I'm dumb. Okay, maybe this works now. I'm guessing maybe this needs to be like perfect. Nope. Still don't run. Does not run. Still outputs really nothing. B at I, A at I. Why is it so weird? Okay. What is it even printing? I think A at I minus 1. This is just a random character. Run. It's still wrong. Is it greater than equal to 0? I guess it needs to be because it needs to count one below it. 2 1s. Some A, some B. Why is it wrong? I can't read this. 113. 1 1 3 and 1. Yes, and then 3 plus 1 plus equals some A plus some B. Where did that line go? Truncate all zeros after. Divided by 2. Oh, okay, see? Divided by 2 does not equal 0. Here it's using remainder. Okay. Anyways, I just want to truncate the zeros. Truncate string. String with leading leading spaces. C++. Why is C++ like this? Damn, in Python you would just like do one thing. Find first not of. Find first last of. Okay, so it's substring. And minus start plus 1. Total sum dot substring dot okay, first not of 0, then first last of 0 minus plus 1. So that gives me the actual length to truncate. Okay. Let's just do it myself. This is too. Okay, so let's say example 70 again. It's 64, 4, and 2. You take 64, 4, and 2. So it has to be perfect remainder besides 1. So because 1 we can't really tell. So string my strings is equal to nothing. How to add back of string C++. I guess you can push back still. So my string dot push back. So I get this multiplier. It needs to be 2. So if I divide 70, if I get the remainder, it should equal to 1. It should equal to 0. There's 0 remainder. But if it's equal to like 8 remainder, it's okay. So if total sum remainder multiplier is equal to 0, then we can my string dot push back, and we're going to push back the character 0. Sorry, character 1. It's a perfect one. Else push back 0. There's only one exception. for the number 1. So for the number 1, you have to do how to check if it's even. If the remainder 2, here I can just do this one exception. If total sum remainder 2 is equal to 1, then we can freely push back a 1. If not, push back a 0. Oh, actually I can just do or total sum remainder 2 is equal to 1 and multiplier is equal to 1. That way that takes care of that case. And we can still do that. Alright, and now we can return my string. That was easier than figuring out that other mess. I forgot to break. Sure. Yeah, we can do as well total sum minus equal multiplier. Alright, 60, it gives me 68. It's still not divisible by 8. And then we can do this until total sum is equal to 0. And we have a breaking condition. Okay, why did that not work? Why don't we STC out total sum? Equal to 0, not equal to 0. Alright, my bad. Okay, you can do the math on this. Multiplier is equal to 1. Okay, total's remainder 2. No, that should be equal to 0. Push back 1. Oh, I think I messed up. Remainder multiplier before 2 is a remainder of 4. In fact, 2 is always a remainder. I did mess up. Maybe I should just start at this. This if statement won't work. You can see what I'm trying to do, right? Okay, so 70 remainder 2 is equal to 0, yes. But I mean 72 remainder 2 is equal to 0, but I mean that would be 64 and 8. I think I have to start at the largest number and then keep going down. How do I find the closest number? I'm cheating. How did you do that? While num is not equal to 0, remainder 2. Remainder is equal num, remainder 2. Num is divided by equal to. What? How does that make sense? Binary R. While num does not equal 0, then we can divide Man. All I have to do is convert decimal binary. I've done this so many times. 85 is equal to 64. 16 to get 80. 4 and 1. So if I start, everything's remainder 2 though, no matter what. Like these are all part of 2. Plus 1, plus 2, plus 4, plus 16, plus 8, plus 16, plus 32. I think I can do this iteratively, so no, that doesn't make sense actually. How do we do that? 17. I know this is 2 to the power of 0, 2 to the power of 2, 2 to the power of 4, 2 to the power of 6. How is that helpful though? Maybe I should take this number and square root it. No, sorry, log to it. What's log 2 of 85? 6. And then that gets me to my lowest number. And then I can just go down from there and minus. Oh, there has to be a better way. I want to know. Binary remainder and binary number. They just print it out in reverse. Binary num in reverse. And here they divide by 2, which I don't understand. Divide by 2. Okay, 85 remainder 2 is equal to 1. What's 85 divided by 2? 42. Remainder 2 is equal to 1. 64. No, I'm back to being confused. How does that work? N over... What is N greater than? N is your number, then your binary number. No, that doesn't make sense. 85. But it's not. That's not correct because 1, 1. Okay, you know what? Let me just do the rest of it. 42 over 2 is 21. Remainder 2 is equal to 0. 21 over 2 is 10. Equal 1. 5 remainder 2 is equal to 1. 2 remainder 2 is equal to 0. One remainder 2 is equal. No, that doesn't work. shift. This is ending by bit 1. And bit shifting. So there's 3 ways. This way, which I'm trying to do, bit shift, and the other way. I don't understand how that one works though. I'm just going to take it though. Total my string dot push back and remainder 2. Total sum remainder 2. Total sum divide equal to. That's what I was thinking would happen. I just don't understand. Like even if this is 4, it's 2. It becomes 2. Which so it's 0, and I divide by 2 again, and then it's 0 2 again. No, that doesn't work. I'm just gonna do what I was gonna do. So int lowest num is equal to pow 2 to the log 2 to the pow of total sum 0.5 square root. So then that would be like a 6 to the power of 2, so that would be 64. Push back. If pow total sum, let's do one more. So if lowest num is greater than total sum, the first one always should be, then lowest num plus equals total sum divided by 2. Other way around. Then we can do lowest num divided by 2, and then my string dot push back 0, else my string dot push back 0. Sorry, this should be 1. This question 47. How did you get, how is it 40, how is lowest num 47? 2 to the integer. Can I have this be an integer too, please? Then you can add 1. Should be 32 now. 32 greater than equal 1. Total sum minus equal. Okay, so total sum minus equal lowest num. So right now we're seeing a 4. 4 minus 4 is 0. 0, okay. It's always going to be 1. Just in case you always have 1 too. Total sum needs to be greater than lowest num, or this isn't gonna work. So this can not do this. So 4. Okay. Final answer. Okay, never mind. How does that even happen? A total sum is 2. Lowest num is 2. Lowest num should be 1 though. 2 to the power of 1 is 2. Ah. I don't understand this one. No, thank you. Array at I is equal to pushback total sum remainder 2. And then remainder. I don't understand. Num is equal to n. I'm losing my mind. The fact that this is saying it works, and I'm doing the exact same thing except in the string, and it doesn't work. Like even the simplest example, 1. Okay, total sum does not equal 0. That's true. Pushback total sum remainder 2. What's 1 remainder 2? Should be 1, right? So 1. Okay, that works. 2 remainder 2 is equal to 0. Okay, so we have 0 now because I did total, or I have 1. Push. Insert. I need the iterator. Why is it printing this? Why is my string being so weird? Is it because I need cast this to char? Probably is. Okay, I probably need cast this too. Cast to char. C++. It I feel like this is not working. Why is my string doing that? I should be able to add the char to the string, right? No, it's still weird. Why is it so weird? Append the char to string. Please. It doesn't work. Push back. Why does it not work? Why does it print something here completely different? My string. What are these characters? Wow, thank you, Xanax fan page, my favorite man in the world. I don't understand. This C++ is killing me. Null character. How to give more space. I think it's ending. First causes a mallet. Reason for using versus efficiency. Oh, that's interesting. I didn't know that though. So I have to reserve space for my string. My string.reserve 64. Okay, no, it's still giving me error. Adding to backplus string C++ null. adding to string is giving me null, C++. Okay, look, if I don't reserve space, and I just say, hey, I have space here. Then no matter what, it just adds all of this. What if I just, instead of adding this, I'm just gonna add a character. Will it add 3 H's for me? It does. So it really just doesn't like this. What if I did char character is equal to that, and then I do this. Okay, now I'm back to here. I think what it's doing is looking at the ASCII table and saying this is a 0 in ASCII and giving me the null character. So what I need to do is add by 35, I believe. Okay, that is what it is. It's not 35 ASCII. So it does direct translation. So I need to add by 48. Then I can do dot. Yep. Okay, we figured it out. It was ASCII. So character to decimal conversion converts the decimal directly, literally. Dot insert at myString dot begin. C++ is so fun. Okay, I understand why this works now too. Okay, please. Okay. If sum equals 0, my string is equal to 0. Please work. This question's my op. Why is there a slash in the output? What? Why is there a slash? No, the way there's actually a slash. Alright. I'm gonna finish this page, okay? I know I've been stuck on this problem for like 1 hour, but I'm gonna do it. 213. Why is there a slash? 213. Remainder 2. Total sum, remainder 2. 213, oh, remainder 2. It's 1. 1 plus 48. Should be 49. And right now it's printing a slash, which is 47. So how am I getting -1? Why remainder -1? Why am I getting -1 when I remainder? C++. Okay, how about I do this? Yo, what's up, Cheese Fest? Okay, I figured out what's wrong. Okay, fine, I'll use long. How much can I even do here? 10 to the 4. That's pretty long. Times 2 cannot be. So probably, yeah, so it's probably not gonna let me to do this. What is longer than long? C++. Long? What? Okay, this isn't right either. This is add binary. I'm very stuck on this apparently. I'm gonna move on. It's too impossible. I tried it earlier and then I couldn't do it, and then I came back to try to do it and I still can't do it. I'm just gonna move on. Symmetric tree. Can you solve both recursively and iteratively? I guess you don't usually check iteratively, and it's interesting though. Okay. Wait, you can help out. Are you sure you want to help out? That would be appreciated. But it's kind of like a challenge. Like I'm supposed to solve it myself. Like this, I think it's this conversion from string to binary. If I was doing it in like Python, I'm pretty sure I could just like write one function and then do it. But here what I have is like converting it either to converting it by 2 for every multiple of 2. But that's clearly not correct. Because I don't think you can convert it. So I'm thinking they don't want you to do it in binary. I was trying to do it in decimal before. Or sorry, just like pure string manipulation, but that was also quite hard. Let me solve it really quick. Alright, Cheese Fest. I believe in you. It's number 67. See, it's also easy. I guess I'm just dumb. That's what I'm figuring out. Tree node. Root iterator. And we got the root iterator going through left to right. So that's going to be ahead. So we can do if root iterator equals null pointer, then we're going to do nothing. Otherwise, we're going to loop to check the left. Dot left is equal to, I can do a bool pass by reference, answer, bool answer equal false, and we'll say, well, always assume it's true until where it's not. Fs root answer return dot. So if the root iterator of left is equal to the root iterator dot right, sorry, if this is ever not equal, then answer is equal to false. And we just need to check both the left node and the right node. So keep on recursively searching, and I can do this last one at the end. Left, right, left, right. Oh, I forgot it's supposed to arrow. Okay, so let's see where I'm doing it wrong. So restart the root left, and then go to the left, and then go to the left, and then go to the right, and then we go here. So this 3. So we're comparing this 3's left and right and seeing if it's equal, but we can't do that. We're actually seeing it if this on the other side is equal. Okay, so that doesn't work. I think we need 2 pointers. One that's searching the left of the tree and one that's searching the right of the tree to see if it's equal. So we go left and then right, and they both have to do the opposite of what they want. So we can do left, right, left, right, and we go here, right, left, okay, forget this for now. So we go left, left, right, I think we need our dash structure to keep track of where everything is. So the root is always symmetrical. Maybe null pointer is equal to false. The root's always symmetrical, right? Let's say we add up one branch. I want to cut it up into smaller pieces. So 2 and 2. We want to look at the left and then look at the right and then see if they're equal, right? When we're here, then this is one entire node away. It's at a different depth. So we can do 1 left here, and that has to be equal to 1 right here. So I don't think we can use depth first search. We have to use breadth first search. So we go 1, 2, and then 2. And then they'll do 3, and then 4, and then 4, and then 3. So we can use a stack to see if it's the same, I believe. Every time it's on the left, we add it to the stack. And every time it's to the right, we pop it from the stack. Stack my stack. So then we can do to the left. We can do to the left first, and then to the right, and then we check. Left first, and then to the right. But what's going to happen is for BFS, we have to check. I think in the middle we can check. So BFS left, BFS left. No, we have to check first. Add it to the stack first, my stack, and then it goes left. Add, right, yeah, okay. How to add one stack sequence, forgot. Push. Root iterator dot value. So we go, let's run it through. So we're at the top 1, and then we go push 1 onto the stack. That's fine. Then BFS to the left. Go here, we push 2 to the stack. Okay, that's fine. Then we go to the left again, push 3 onto the stack. Okay. Then we go to the right, push 4 to the stack. Stack, there's nothing left, there's nothing right. So we go all the way up back, and then we're done with all the lefts. And there should be 4 things put on the stack. So we've done going through all the lefts. Push 1, then we go left. Push again, go left, push again, go left, nothing there, go right, nothing there, up, left, nothing there, right, there is something there, and push 4, left, right, nothing there. Now at this point we've only gone all the way through the left, now we have to go all the way to the right. I think it's easier if we do this twice. No, I don't think so. Okay, so we pushed it all. Left, left, right. That's 4. So now we have this list when we're going all the way to the right, because we went all the way to the left. So we go right 1, it's a 2. That's not really helpful, actually. Maybe I should do this at the end. Let's see what happens when we do it at the end. So we go left, left, push. Then we come out, go 4, push. Then we come out, and it's a 2. Left, right, push. Up, right, left, right, push. Up, 2. Up again, 1. Then we go to the right. Then it's left, right, push, 4. Then we go up here, and then right here. Left, right, nothing, right, left, right, push, 3. Up here, 2. And then that's it. Okay, what's the symmetry here? 4 to this is not symmetrical. Left, left, push. Okay, let me try left, left, 3. Left, 3. 2, 4. Right. One. Left. 4. 2, 3. 4, 2, 3. 4, 2, 3. Okay, we're gonna do this right here in the middle. Index 1. It's not gonna be a stack anymore. I changed my mind. I'm just gonna make it int array. And maybe have this be able to do like 1,000, 10,000. So 3 and 4 should be equal. 2 and 2 should be equal. 4 and 4 should be equal. Okay. So since all that is equal, oh, there's only 1,000 nodes. Okay, so that could be 1,000. Because if not, it's left, add 2, and then add 3, and then that's right, left, 1, left, add 2, add 3. Yeah, it's not the same as this. So we have to get this size. Okay. So then for I equals 0, I is less than we have pointers going inwards. The thing about it being symmetric is it always has to be odd because you have the root node. And we're always going to try to ignore the root node. Stack.size I plus plus. So we go from 3. So if my stack, okay, this doesn't need to have answer anymore. At I does not equal stack at my stack.size minus I, then answer is equal to false. So for this is 0, 1, 2, 3, 4, 5, 6. 6 over 2 is 3, so 0, 1, 2, 3. So we should have stack up my size 0, 1, 2, 3, 4, 5, 6. How does my dot size array? Is it so size? So it should be 6. No, it should be 7. Because this one would print all of them. Let's see. What? How did I? Yeah, it doesn't. I've been using that length. Oh my. Standard library. Okay, size. What is this? 5, 0, 1, 2, 3, 4. Okay, yeah. So it gives the actual size, like how you would count it. So this would give 7. 0, 1, 2, 3, 4, 5, 6. So 3. So this is 7 minus 0, which is out of range. So I need to minus 1. Pass by reference array C++. How do I write that? Or I'll just do the pointer to to my stack. That should be easier. Oh wait, that's already a pointer technically. Should be chill. Member reference int 1000 is not structure or union. There. Vector int pass by reference. You mean answer. Where'd it go? Will answer equal true. Okay, so we can do this. It gives me this. Whoa. Pushback. Hello, Cheese Fest. How'd it go? Yes, I did mean to write the putting thing. Yay, it works. Did it. Almost passed all of them. Failed at this one. 1, 2, or 2. 2 are null. If it's null, then I don't do anything right now, but while you were doing that one, I almost solved this other tree one. It's going all right. This is an uneven tree. Oh, it drew it for me. It's nice. Oh, it fooled me by having the values like this. Well, that's really hard to... but kind of weird. Why was it so weird? Okay, right now I'm preserving the value. I need to preserve order. Also, to preserve order, I can just do the same thing. Why don't you explain how you solved it to me in your chat, and I can see. I think I just do this again. So, left, add 3. Then you go here, add left, then add right, then add left, that's okay, then add left, and then add right. So these two are flipped. So we can start at half. But then that would be compared to this where it's left, the two trees at the same time. I was thinking about doing that. I think that's one way you could solve it, but I'm just iterating through the entire tree recursively first, and then just storing the values in order after I traverse through it breadth firstly, I think. So I traverse it breadth firstly and then store the order in a list. But right now I'm only preserving the value. I'm not preserving the direction. I think if I visit two trees at the same time, that would also work. That's what I was thinking of at first. But I decided to do this way. Left, left, right, left, 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 right. So this one is left, 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 because there's no right. No, that doesn't make sense. I got submission. I got all of them right except this one. I need past 4 more, because the way that this tree is structured, the values are the same but it's not symmetrical. So I'm guessing yeah, I don't know. Please don't use a stack, trust. I'm not using a stack. I just named my integer array a stack. Maybe I should call it a list. Is there a disadvantage to making it I guess it's an array technically. Anyways, is there a disadvantage of using an array versus searching at both at the same time? I guess if you search it both at the same time, it's a bit more efficient with space and time. Direction list, I'll push back. Okay. So here we have a list of directions. Direction. Actually, I won't print it here. Yeah, false, true, false, true, false, false, true, false, false. So we go left, false, then right, true. Let's see one that is symmetrical. This one should be false, true, false, false, true, true, false, false. There's absolutely no pattern to this. False, true, false, false, true, true, false, false. Maybe you're right. Maybe this isn't working. It's kind of not. That's probably why. Can't look at the directions. I think traversing both of them makes sense. I just wanted to do it without needing to do that. Okay, I'm gonna come back to this as well. I like thinking about it. Symmetric tree. 104, maximum depth. Huh? Why did they... Okay. Okay, we can go DFS. For real this time. As you said, root does not matter, just root tree left, root tree right. There's two separate trees, DFS on both of them at the same time to see if they're mirrored. Yes. That's what I was thinking of doing before I thought of the other thing. Which is probably... I probably should have done what you said. That sounds a lot smarter. For sure. I'm gonna go back to that right after I solve this one. 3. Left, right, right. 3. So I think every time if root, this is some good advice you're giving me. I like that. Thank you very much. If root is equal to 0.2, we can end. Then we can go root.f. If depth is greater than equal to depth plus 1. Oh, that's always true. We have to store the depth only when the next depth is greater. So to do that, we should return DFS DFS left, right, left, right. Okay, so let's say we go here. We go left, depth is 1. How do we know that? Well, we're keeping track of depth. Depth starts at 0. Left here. Then go right, root 0. No pointer, no pointer. So we should always just keep track of the maximum depth. Left, right. Then we can do max depth on the outside, so it's global. And we can do if depth is greater than max depth, then max depth can equal depth. Can I do global variables like that? Max depth number. They named the function the same as that. value of depth, please. Pass by reference value. Get value of pass by reference. C++. Int temp is equal to I swap. How do I get the value of a pass by reference? Man, honestly, I don't need pass by reference this number. I'll just do 0. It's going to end one depth below because this is only happening after the null pointer. Okay, let's see. Okay. This one. Nice. Alright, we got depth. I'm gonna try what you said, Cheese Fest. I think I can do it if I do that. Okay, let's go back to symmetric tree. And I'm going to instead do all of this. I'm going to search through both the left and the root of the right. And we don't need this list anymore. And we're going to go through both of them at the same time. We can do BFS left. Oh, and then I guess we want answer again. Left, left. So we have the left node and the right node. So we want to see if the left left and right as two separate trees and DFS on both of them at the same time. So here the right needs to equal to the left, and the left needs to equal to the right. So traverse single tree, node, tree. If the tree is equal to null pointer, then we return -1. Else traverse single tree. Tree at left. Traverse single tree at right. return at the end the tree's value. And then here we can say if traverse single tree at tree is equal to traversing, sorry, at left. And they're equal, but you can't just return one value. My when he sees that's gonna be me for real. Is there actually a 5-line solution? Why am I doing all this? Okay, I think I am making it too complex. I agree. I don't understand. Okay, I probably don't need this. I probably just need to look at the left and look at the right. And then go through it. Can I just return the return the node value? I'm actually so bad at using these trees. Okay, look, okay, yeah, left and right. Right as two separate trees. Okay, I've split them up. So I have the left node and the right node. Just treat root left as two separate trees and do DFS on both of them at the same time. I think I'm just having trouble doing DFS on both of them. How do you run it on both of them at the same time? Like, run it twice? Like this. If you run it twice like this though, it's not gonna be equal because it's gonna go left, right, and this is left, right. I feel like I need to marinate on this. I don't really know. I don't really know how to solve this one yet still, especially not in 5 lines. Left, right. Left and right. So if we do go here and go here, and we traverse using BFS, we just want to see if they're symmetrical. Left, right. Bro, I don't understand. I'm coming back to this after. I need time. Are all these tree questions now? Binary tree, Pascal's triangle. Okay, I guess I have 3 more trees. Sorted array to VST. Zero, -3, 9, -10. What? Given an integer array nums where the elements are sorted in ascending order, convert it to a height balanced binary search tree. So I have to make a BST that's height. For I don't know how to do that. -10, -3, 5, and 9. That's the input. -10, -3, 0, 5, 9. Ascending order. -10 to -3, 0, 5, 9. Then we can insert it 0, -10, 5, -3, 9. Binary search tree. -10. Okay, I think I need to dynamically allocate some more memory for this because I probably need construct. Yeah, I need to construct a new one. A new one. So that can be in the middle of nums. Nums at nums dot size over 2. Then we can apply construct est. I guess this isn't too hard, it's just you're just making a BST. I've never done that before. Tree node. Tree. You'll need this. Iterator. If the num is less than I think I have to look at how to create a tree. I don't even know how to do that. Learn how to create BST. I always come into doing leetcode so confidently, and then I'm like, actually, I don't really know. I don't really know what's going on actually. Determine if it is height balanced. This one is, yeah. This one, no. Actually, I have no idea how to do this either. Learn how to balance and height balance. These are good questions. I want to learn on my own time though, because I'm gonna figure out how to do ones. Minimum depth. Isn't this just the question I had before? But I just need to change this to. stand up number. Can we start like a high number? 500. Yeah, I guess it doesn't really work because then it just stops instantly. Output was 4, 2, 0. Honestly, I don't even know how to determine min and max depth, so maybe I should learn that. Min and max depth determination. Alright, let's keep going. Path sum. Given the root of a binary tree and an integer target sum, return tree if the tree has a root to leaf path such that the values. This also looks hard. Left, 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 right. I just need to keep track of cursor. Cursor, void cursor, tracker. Sum is equal to target sum. Sum tracker with root 0 target sum plus equal to the root. It's val. So 5. Then we can do cur sum tracker with root at left with the cur sum with the target sum. And then we have to do it for the right as well. Eventually it will be equal to null pointer, like here at the end. So left, left, left. So we did 5, 9, 11, 7. Then we get to null pointer. Root is equal to null pointer. Is the target sum equal current sum? Then issue is true. But this only happens there. Oh, I like that. I like this answer. Does leetcode like this answer? No, because of root. I always need to put in the use cases. Alright, let's see. Is this correct? Can you give me the money? Output true. Target sum is 1. 1 to 2. Target sum is 1. Oh. Oh, I guess that doesn't work, huh? Target sum is equal to 1. And it's the root. And root does not equal target sum. val. What? But there's an and there. Should I even should see the false. Ah, fruit. And root left is not equal 0.2, and root right is not equal 0.2. They really give you the most edge cases of the world. Okay, you're technically true. If root how? 1, 2, target sum is 6. Okay, so we got 1 plus 2 is equal to 3 plus 3 is 6. How does this even become true? 1 plus 2 is 3, 3 plus 2 is 6, 10, 15, 15, I'm confused. See, if I put it here, it's going to check on every other one. If I put it here, it only checks, I guess, it would check here, because it checks the right. Right's equal. But this isn't a leaf. I have to check if the root, the previous node, per some root val. Ah. If root is equal to null pointer and previous left is equal to null pointer, can I just do the previous left and previous? I should do this after. Okay, we're back. So back. Oh my. Alright, how does this one look? Target sum 0. Okay, root equal null pointer. No, that's false. That doesn't happen. Root is equal target sum. Yep. And left is equal. Yeah, that doesn't happen. Target. What? How is this true? 0. Okay, maybe I don't need this one. I don't think I do. There we go. That breaks logic. Nice. We did it. All right. 112. I actually understood what was happening in that one. Took a while to write. Given the integer of num rows, return the first num rows of Pascal's triangle. Each number is the sum of the two num rows of 3. So we populate a new integer array. This num rows plus. So this is how many we populate. So we generate a new array every single time with 1, 2, 3, 4. So we use I as the last source. So the first one that we have is pretty easy. It's just 1, but we want 1 at the every end. So how do we make a new vector? Integer array. have to have integer array dot append 1. Oh no, this is gonna be so hard in C++. Integer array. Bro, I have 230,000 drop frames. Okay, next time I stream I gotta fix my internet. Also, this should be hidden. I don't know why it's not hidden. There you go. Okay, 1. I'll even create a new array in this integer. Nope. I dot append. I guess 1 is fine for now. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. I wonder if I even need to push back an array. Probably not. Okay, let's see what my solution is. Okay, undefined behavior, std vector, no. Vector array, how to push empty vector to vector. Push back std vector. Push back vector int. Push back vector. Vector to vector. What? 2D vector. Can we not have that? Push back vector in. Okay, so it's just this. Okay, cool. Now I just need to do processing. 1, 2, 3. Alright, so we got our Pascal's triangle. Now we just gotta take only if J is now we have to take our previous two above. But only if J is greater than 0, 1, 2. If J is less than equal to J2, then 2. Okay, let's just focus on that restriction first. Okay, I think that's the other one. But anyways, so here this is J is 0, 1. Sorry, maybe I. So this is I, and J is greater than or equal to 1. 0, 1. 0, 1, and J is less than I. Then we can do Pascal's triangle. Or else we do this. So then, if it's here, then we push the previous two values. Integer array at I minus 1, J minus 1, which should be 0 plus J nice. Okay, I think that's good. There we go. Beat 17% of the people. I think there's a way to do it. There has to be a way to do it not derivatively, right? Yeah, I'll figure it out later. No, I don't think there's a point of streaming if I'm dropping every single thing. I dropped 250,000 bytes. It's so sad. I'm just going to take the last solution and copy it, and we're just going to do this at num rows minus 1. try to apply 0 offset to I don't understand how this initializing a vector works. I think I did it though. Row index is equal to 1. How did this happen? I +1 this though, so it should be one more. I'm so confused. Okay, I guess that works. All right. Well, it says I beat 100% of people, so I guess the solution's good. I wonder how people actually do Pascal's triangle too. Hey, look at the solutions. Oh, right. Oh, so there's a mathematical way of calculating the row. Can I do C++? Oh, choose. The previous element or can we calculate 4K and the next pre pushback pre. Ah. So you can push back. This is equal to the next value. That's cool. So if you do the math correctly, you can do that. Okay. Ooh, sliding window time. No transactions are done. Buy on day 2. Price is equal 1, 2, and sell on that day. Interesting. I is the price of a given stock on IF day. What's the maximum? Choose a single day to buy one stock. And a different day in the future to sell that stock. Well, my naive approach is look at every... Okay, what if I stop steering on Twitch? Does that help my frames? Actually, yeah, it went straight up to 2700. Maybe I can't dual stream then on this internet. It's okay. I'll just stream on Twitch. I said I would finish this entire page. But I can see now that it's not happening. Implement stacks using queues. That's fun. Valid Balladrome. Okay, one, it can't be a minimum index. The index has to be higher as well. So if we did a really naive approach, we can do something like this and be like, hey, if the price is at I is less than prices at J, do profit is equal to prices at I prices at J minus prices at I. Just return profit. I should probably do like prices is null. Prices is I. So 1 is less than the last one. That way we ensure maximum profit. There we go. Naive approach. And then we can do like sliding window or something, which I still don't know how to do. Man, it won't even let me process all these numbers. Oh, that's a lot. Oh, we can save time by doing this -1. Alright, let's see if that works. I don't think this test case is a big fan. Alright, so this is too slow. How can we increase it? Well, we can have we can have a pointer to a minimum. So this looks for the minimum and the maximum. And check their indexes. No, that's gonna take too long too. really, I don't know these questions with 1D arrays. Question with 1D array. I don't know how to do. Let's go back to here. Can do s at I is not equal to s at s dot length minus I minus 1, then is true is equal to false. We're looking at the characters. Okay, my bad. Remove all lowercase, turn all uppercase to lowercase C++. String. To lower. And put string to lowercase. Okay, we can just always do this dot to lower. That's fine, and then we just need to get rid of. Man, if this was Python, you could just do the function. How to get rid of all punctuation in a string C++. You're gonna say good luck. I should just form a new string based off this string. Get rid of all punctuation and lowercase all letters. I don't have to do this. New string. For I equals 0. I is less than s length. I plus plus. New string dot push back. It's not equaling. And the if s that I cast it to an integer is greater than 65 and it's lower than to lower s at I. ASCII table time again. We got 65 to 90, but it's too low, so 97 to 122. Wait, is that inclusive? 97. Yes, it is inclusive. Let me push back. For lower, push back, new string. Okay. Got rid of all the punctuation. Man, a plan, a camel, canal, Panama. I forgot to lower this. Run. A man, a plan, a canal, Panama. New string. Submit. It's gonna be like a string with nothing in it. It's gonna fail instantly. Length of 2 counts. If new string dot length is less than equal to 1, return true. What? How's that false? Alright. I guess if it's not back and forth. If new if string is equal to compared to literally nothing, then return true. Equals 0. Expected true when it's punctuation? I'm so confused. That should be false. I actually can't just submit this without that one. So a period is true, and that's also true. So if it's empty, it's true. Because it needs to mirror. Output true, output false. I don't understand. Why is A false but P true? Like this is okay. It says ignore all punctuation and zeros and whatever. So this string is just P technically. But if I were to submit this, If the string is A, then now it's true. That's my solution. I don't understand. Why do you not like it when this should be the same as this? This is the same. 0p turns into A, which is the same as what you've been doing. Removing all alphanumeric characters. That means zeros, that means P. Are numbers alphanumeric? I don't think they are. Oh, it includes numbers. Now we know why. The more I learn. Okay, it's my bad. 48 to 57. SI going to equal 47 and int SI less than equal 57. 48. Includes layers and numbers, so I'm just done. I forgot one more bracket here. Alright. I got rid of the print statement. Hopefully it should be faster now. Yep, good enough. 125 valid palindrome. Single number. Every element appears twice except for one. Find that single one. Constant extra space. Okay. That means you can't just count. Four plus 1 plus 2 plus 1 plus 2. Well, we just keep oh, this is kind of easy. Size plus. Why don't we keep track of every single one by saying we will minus if the remainder of your number is equal to 0 with a total sum. Sum plus equal nums at I. If some remainder return sum. Nums at I is equal to 0. We need one more condition. If sum is equal to 0, then we can do this. Oh, maybe I should just do that. Okay, so 2 remainder 2 is 2, or 0. Minus it. sum is 1. Add. Everything remainder 1 is it works. Oh, my plan fell apart. 4. 4 plus 1, 5 plus 2, 7 plus 1, 8, 10. Actually, I don't know. I don't know how to do any questions with linear arrays. I'm sure if I knew how to do one, I would know how to do all of them, though. I know you add, and sometimes. Okay. Hint time. Think about the XOR operator properly. Okay, well, XOR gate is 0, 1, 1, 0. So if there's more than 1, then it becomes... Zero. Huh. Huh. Can do. How does Zor have anything to do with that? I'm still confused. I don't know. I don't want to use hints. I want to figure out myself. Okay, Zor property 2, 2, and 2. Okay, let's think of this in binary. So we got 1, 0. Oh, binary 1, 0. Zor it with the sum. Sum Zor nums at I equal to, well, Zor property is if there is 1, it will turn into 0. So here we should have it. Okay, right now our sum is 2, for example. 2 Zor 2 is equal to 0. But if there's only 1, then it would be equal to 1. I don't understand though. How does that work? If you have like 2 plus 3 then you would have 1 0 plus 1 1 3. Then that would turn into what? Maybe the solution is to always just XOR it. Two, XOR 2. Maybe we just take. Okay, I need more hints. I try my best. More hint, please. Oh, that's the only hint. What? So 4, 1, 2, 1, 2. The answer is 4, but how do you know that? 1, 4. Maybe I have 2 pointers. One with the one that contains in duplicate num2 equal nums at 1. If nums at 1 and nums at 2 equal to 0, then it can't be this number in my num. I don't know, 0 for now, it doesn't really matter. So we know num has to be at I, but we have to continuously update. We have to continuously update num1 and num2. To continuously upgrade num1 and num2 to keep track of my num. So if it is equal to 0, then num1 should equal to the num at this point, and then num2 can always just equal whatever nums at I is. Effectively, you don't even need nums2. We can just do this. No, we need nums2. Okay. Okay. So nums1 is 4. Nums2 is 1. 4 XOR 1 is not 0. 4 XOR 2 is not 0. 4. Okay, this should be nums1 just in case it's num1. 4 XOR 2 is not 0. 4 XOR anything but 4 should be not 0. So, but if it is, then num1, my num. I don't need my num, I can just use num1. This is my holder, placeholder, and then I can use XOR. Ah, there we go. Now I'm processing. Okay, so 2, XOR 2 is 0. So I know that it can't be, I know it can't be num1 or num2. It has to be the next one that I should check. So it should be I plus 2. So if I'm at here, 0, 1, and I guess I have to minus 2 in response. So 0, 1, so XOR together. It's wrong, so num1 is equal to nums at I plus 2, 0, 1, 2. And then then I have, and then yeah. Yeah, that works. I don't even, do I need iterate I think? I think I do. No, but then I'll skip a number. Okay, I think that's fine. What? Why does Zor have lower precedent than equals? That's interesting. Return not one. Okay. Alright. Yeah, so I really could. Buffer overflow at solution. Let's return nums at 0. This is going to go negative. Output 2 expected 1. So 0, 1. So then I is equal to 1, so we're starting right here. I can equal 2 to be honest. I is less than nums dot size minus 2. Oh, so that never runs actually. So 0, 2. That needs to be 0. Nums at size is 3, so this needs to be minus 1. And then nums. I can start at 2 because this is nums 0 and nums 1. So then that starts at 2, so this number. But we're still checking num1 and num2. Let's just start at 0. Num0, num1. I think this needs to be plus 1. Because we need to track one number ahead. There we go. Hopefully it doesn't overflow, it might. One and 0. 1 Zor 0 is still 1. But 0 Zor 0 is also 0. When or num. I feel like my brain just expanded by so much. Or num. I need to make a special case for 0. Because negative numbers, same, this still works. Positive numbers, it still works. It's just 0. Well, if 0. If 0 return true. If this false. No. If 0 is equal to 2, return false. Else return true. Okay. Now I need 0 counter. If nums at I is equal to 0, if 0 plus plus. Special case, special case. Anything else, it doesn't matter. Wait. There we go. I can't realize I can't do that. Okay. What? Equals 1. Okay, there you go. Okay, cool. I like that. Let's see. Alright. That's fine. 0, 1, output 2. Now we can check why our logic is flawed. So 0, if num1 XOR num2 is equal to 0, oh, that's not equal to 0. So the next number it comes up to is here, 2. It's still 2 though. Oh, I see what I've done here. They're both unique. We don't know which one to choose, yeah, because it's at the very beginning. Num2 is equal to 1. And then I plus 1, 2, 1, 2 and 1, I plus 1, 2 and 2 is equal to 0. So we skipped over. We skipped over 1. Num1. I shouldn't compare num1 to num2. I should just have num1 and num2, and then it can just be equal to I. So if num1 is 0, num0 or num2, sorry, nums at I is equal to 0. Nums at I. Well, it's just uncertain. Like here, it's certain. Here, we know. I don't know. Because it needs to just compare itself to everything. Or be first, or else there's no way. It's 2. Yeah, I really need to learn how to do these questions with 1D arrays. I think I'm really close. I think I just need to think about it a little bit more. Okay, I'm gonna move on. I just need to think about it a little more. Linked has cycle. Given the head of the linked list, determine the linked list has a cycle towards it. Next. Wait, there's a cycle in the linked list. There's some node in the list that can be reached again by internally. Pause is used to denote the index of the node that tails next. Pause is not a parameter. Position is equal to what? Pause is equals to 0. Can I just check if the list value in a hash map unordered, let's do sets of list nodes, my list nodes, and then we can do while I can do list node iterator go ahead while head iterator does not equal null pointer. My list knows dot how to add to sets dot insert my set dot insert it. What? Why does this have an iterator? Can I just insert into it? Thank you, Geek to Gates. I can just insert into it. Iterator. And I think this returns 0 from what I remember. It returns 0 if it already exists. So if it already exists, then it's cycled. Return true. Else return false. It probably will reach null pointer, because if it doesn't cycle, it'll reach null pointer and return false. I remember doing a question with .second. Iterator equals iterator next. There we go. Let's see. Hey, we on top, huh? Alright, I like that. Short and sweet, but requires a bit of thinking. I wonder how people did it faster though. I don't know. Alright. Linked list cycle. I think I'm gonna just keep going. I need to get to 225 today. Oh, that's alright. Okay, I'll get to 200. Ah, binary pre-order. What does that mean? 1, 2, 3. 1, 2, 3, 4, 5. 8, 1, 2, 4, 5, 6, 7. Okay, I can do this. It's just DFS. Void DFS. Tree node. Node vector int pass by traversal array vector int traversal array DFS root traversal array return traversal array if root equal null pointer return false. I wonder how you do these in Python. What does Python look like? Oh, I don't like that at all. I'm gonna go back to C++. Alright. If node equal null pointer else node DFS node at left DFS node at right traversal array dot So we go left, left, left. Oh yeah, we have to add first. Add, then go left, add, go left, add, left, right. Go right, add, left, add. Yeah, okay. Push back. Node val. I think that should be it. Return false. Why did I say that? Return empty. Return vector int. Traversal. One of these days, I'm just gonna press submit first try, and it's gonna work. Not today, though. All right, that's it. We love C++. All right. Which one is this one? See, when I was thinking like leetcode easy, so I was hoping it'd be something like this. You know, nice, easy. Make sure I know what pre-order traversal means. Now I know what pre-order traversal means. It means in order. Because I kind of forgot. Post traversal. Well, I'm just going to take the pre-traversal and copy and paste it. This happens at the very end. 1, 2, 4. All right, it's the fastest one ever. Can they all be like this, please? $157 time. What? 160 time. Intersection of two linked loads. Okay, alright, I like this. The value program is not given these inputs. The value of the node where the intersection occurs is 0 if there's no intersection. Yeah, firstly. Okay, I see. I have to prove to the judge I'm worthy. I think this is exactly like the set one I just did, where you just have to traverse all of it and see if they have the same address at any of them. Because there's no way to know unless you've traversed all of them. I think I could just do this again. Iterator A. Sorry, this is iterator B. Return list node. Well, yeah, we'll keep inserting. And then for A, I don't ever want to stop inserting, I don't think. I just want to keep going until I'm at the end. I mean, it's saying, is it cyclic? No cycles. Okay, the first one should just keep inserting no matter what. It doesn't matter. Yeah, it shouldn't matter until I get to the end because there's no cycles. And then this one, we'll just wait until if it's sure. If it's sure, it's sure. And then we can return iterator B if this happens. If not, then we return null. Bleh. Bleh. Iterator A. Iterator B. He told me to he told me to return null. Alright, I did it. Good work, gang. I think using the pointers like this is very useful. Very easy to find cycles. If not, I don't really know how you would do it. I could go faster. It's okay. Intersection of linked list. Missing ranges. Not one. Not. I don't got premium. Maybe one day I'll get premium and just do it all. Given an integer column number, return its corresponding column title as it appears on an Excel sheet. AP ZY. Why is ZY 701? AP A to Z AZ. It's multiplied by, this first one's multiplied by a factor of 26. For all okay, we're converting all of this to integers and minusing 65, okay? Oh, I have to output the string. Okay. Cool, I can do that too. All I have to do is add 65 for the first one. Add 64 actually. Okay. Number that push back column number remainder 26 plus 65 at I need to go backwards actually. Remainder 26. Okay, remainder 26, so that should be 1 plus 65 and chart. So I didn't need that. I thought I was doing string to integer. Column number divided by 26. So we do 28. What's 28 over 26 is 1.2. I need to seal this one. Let's see. What's the sealing function? So 2. Oh, actually, no, that's still 1. 1 2, 1, 26, remainder 28, 2 plus 65 is, sorry, this has to be 64, this is B, and then 28 over 26. 6 is 1, so it gives me 8. I can't push back this actually, I need to insert with my column. I should change this to my column. Dot begin. Okay. 26. Okay, 701. 701. That is not gonna work. Remainder 26. It's 25. I'm just gonna do a while loop. Over 26. Over 26 is still 1, so maybe while column number is greater than or equal to 1 point. 1.05. I don't know. Oh, 1. 701 over 26 over 26. It's 28 over 26 is still 1.07. And then it goes to 0. 701 is... Why is it not dividing by 26 well? Is it 27? I think it's 27. Divided by 27. 28 over 27. Yeah, I definitely should go with 27. Okay. Wait, how many characters are there? 65 to 90. 90 minus 65. 25 characters plus 2 because they're inclusive. Right? I think I'm doing that right. If I'm doing 25, it doesn't work. So I have to do 27. How many characters in alphabet? 26. Okay. Yeah, so 20, so we round up a little bit. 26. So then 701 remainder 26 is 25. And 25 plus 64 is 89. Which should prove to me this should be 27. Because I think I need... No. Yes, Y. I need the letter Y, which is... Okay. Lots of string manipulation I thought of. What? Why? Oh. What did I do that? What column number is 1? What's 1? Remainder 26 is 1 plus 64 is 65. Why? This reminds me of the last time I was doing this. It's because it's 1 exactly, right? Greater than 0. Y and Y 26. But if I do 26, it's not gonna work. Okay, we gotta figure this out. A maps to 1, so that's why it's a 64 difference, because we're going from 1 to 26. Z maps to 26. So this needs to be remainder 27 then. Let's say we have a number 701, then it can only be 1 to 26, it can't be 27. (26). 102. 26, 27. No, it has to be 26 because it gives me the range of 0. This has to be 25, and this has to minus by 1, and this has to be 26. I don't know bed math, but I think this might be here. Column number is always going to be 1 to 26. We minus 1, it's 0 to 25. Zero to 25. 0 to 25, which gives you 26 letters. 0 to 25 plus 65. 25 plus gives you 90. Index number 3 balance type first year. Column number minus 1. So 701 minus 1. 700 remainders 26 plus 65. Not I don't know, I should get the right answer. I think I should do column number minus 1, right? Because that's what I'm doing. 26. It's minus 1 over 26. Minus 1 over 26. Let's do this first. Minus 1. 28 turns to 27. 27 over 26 is 1 still. Yeah. Yeah, that should work. Boom. Alright. Big boys. Big boys. Okay. Cool. This is an interesting one. It's about character manipulation, but it's interesting because it's one character above the actual Excel sheet. Majority element. Given an array, return the majority element. I think you just need a count of the most majority so far. No, it's another one where you just like add it and then okay, maybe this is my chance to learn. I'll just do it the like dumb way first, and then I can learn how you're actually supposed to do it. Alright, if j equals 0. One. Two plus two. I still don't know. Size. Yes, number of occurrences. This is what I need. Equals the target. To majority element. I don't know. I don't know how to do this either. Maybe I should just do the sum. 3 plus 2 is 5 minus 3 is 3. I don't know how to do 1D array problems. I just did this one, no? Oh, it's the other way around. Oh, I just did one way, so I can just do the other way now. Slowly losing. I'm slowly getting tired. This is good. I don't think I haven't worked since I'm tired in quite a while. I think I like this. Why? No, I don't need any of that. Column negative 0. So if I see 1. Plus equal okay, so this is 2 1, so no, I can't do this. I just need the first one. I need to include the first one. Plus equal column title at I minus 64. Turn this into an int. Then you multiply by 26. Okay, and now I even need this. A turns to 1. B turns to 2. It's 26. Oh, we need the multiplier. All right, run. Darn it. I was so close to not having any errors. I forgot this though. Run. I'm incorrect. How did I get negative 28? That makes no sense. A turned into an integer. Okay, come on. I need to get to 700 or I'm gonna die. 0.65. I see the errors in my ways now. Nice, I did it. Okay. Alright. Okay. Well, you ever try being a long before? A long. Why is the third test case super big? Let me run it. All I had to do was give it more space. And just like that, we win. Reverse bits. There is no unsigned both info. Oh, I love binary, but I don't know if I love binary this much. Input 0, 0, 0, 0. Assigned integer. Reverse bits. So you should go into every bit and reverse it to input rather than unsigned integer or unsigned integer. UN32. So for this one, you reverse all of it, which is also UN32. Well, this should be interesting. How would you optimize it? I don't know. Never do it. How many more problems do I have? Oh, two more. Okay, I can do this. And how do you reverse a number? I did it in Verilog like a couple days ago, maybe like last week. There's two methods. You do it like as a string because you can concatenate numbers, or you could do a binary representation somehow. I think if you not the entire number, that doesn't really help you. Okay. I don't know. How to revert. No, I can't just Google it. What if I reversed it? So I'll start by remaindering 2. This remainder 2. Remainder 2. At the very top, which gives it's pretty big. And then I'll go from the other direction. You see what I'm saying? Equals 2 pow 2 32. Wow. My max num. Oh, my max num is square root of 0. My max num over 2. UN32, my min num equals 0 equal 1. And my min num times equal 2. New sum. Okay, so look, we start from here. If n modulo my max num is equal to 0, I guess I just do n divided by equal to 2. New sum plus equal my min num. So for example, here is 1 plus 1. Here's 1 plus 2. I think that works. I'm not certain though. That would be so real. I have no idea. I forgot this. but I think it should work. Oh no. What? But it's UN 32. That means it could do 32. I think this has to be 31. Time will be exceeded. Come on, be real. How's time will be exceeded? Okay, I'll figure this one out later. That one's going in the shelf. Given a positive and integer array function, sub bits, finding number. Oh, bit 3. 3 bit sets. What? 1 bit set. 30. Wow, and over 2 does not equal 0, then no bits is equal to 0. We can just keep dividing n by 2 until we reach 0. Return numbits. Numbits. $28. Okay. We gotta do this again. Remainder 2. Remainder 2. I plus plus. If n remainder 2 is equal to I think if it's equal to 1, if it's equal to 1, then we add 1. I believe, I'm pretty sure. We're so up. We're so up. We're so up. Number of 1 bits. 202. Happy number. I'm gonna be happy if I finish this one. Happy number. Happy number. Starting with any positive, replace the number by the sum of the squared digits. 1 9 squared. 6 8 plus 2 squared. 6 squared plus 8 squared equals 100. 100 is equal to 1. Return false. Wow, n does not equal 1. And have to get all the digits in n. Wow. For n I equals 0, I new num equals 0, while n does not equal 0. We'll do n over 10 divide equal 10. And we can do our new num is equal to n over, what's 19 over 10? Remainder 10. Pow, that's by 2 plus equal 82 and equals new num. If does not equal 1, or it will stay or loop endlessly. N is equal to 1. While n until the number equals 1. Two squared is 4, 4 squared is 8, 8 squared is 4 squared 16, 1 squared plus 6 squared. I guess this has to be greater than equal 10 to keep repeating. I don't know. My brain doesn't work. Oh, I almost passed. Is equal to 1. Return true. I almost passed that one. Or n is equal to 7. Did I do it? Nice. I want to be so real. I don't process what I did there. How did I do that? Oh, I forgot to paste my last. 2. Oh yeah, how many till 2? 25. Oh, easy. I can do that actually. I just gotta stop being a baby. Happy number. Come on, stop being a little bit. I need to finish at least one page or I'm gonna be here all day. And then I gotta do 2. And then I gotta go all the way till 60. So page. 6. Oh yeah, I just need to go page. Ah, yes, page 17. 17 days. I can finish in 17 days. I just need to dedicate a little bit of time doing this. Look, refresh. I did almost all of these except the hard ones. Look at that. Look at 40. Oh, 43% acceptance is terrible. I really need up that. I should stop spamming accept submit. Whatever. 45 out of 832. How much percent am I? I'm 5.4% there. Alright, and I'm gonna keep being that if I don't keep going. Okay, this should be easy actually. I can do this. Okay, easy. If head equal null pointer, return null pointer. Else link list node iterator is equal to head while iterator is not equal null pointer, and iterator is equal to iterator dot next, but also if the value of iterator is equal to the value, then iterator next is equal to iterator of next. But what if that's equal to null pointer and iterator next is not equal null pointer? But what if it's the last element? Okay, one, we go to the value, no, next, okay, value. Do we care about lost memory? I guess we should, yeah. Huh? List node delete node is equal to iterator delete. Wow. Iterator next, and as long as it's not null pointer, then it should be fine. What if it's at 6? Iterator no value, yes. Delete node is equal to iterator not next, which is null pointer. I need to do the next. Yes. Actually, or else I can't link it back. So I start at 1. If I start at 1, I need to keep a previous. Equal iterator next. Next is this one. Delete that one. Val is equal to val. Okay. Sorry, next, because that's not equal next. Rev is equal to iterator. Iterator is equal val. Delete node is equal to iterator. Revs next is equal to iterators next. Delete this node. Delete node is equal to null pointer. It's fine. Okay. Well, if there's 2 though. Iterator val. Use the pre. Next, yeah, it still didn't update, yeah. Okay. Next, there's no chance. Iterator doesn't have null pointer. Protect yourself. run. Return. I didn't touch your head. It should be the same still. Heap use after free read. Is this not equal? If iterator equal null pointer, then break. I didn't say what's iterator equal to. Iterator previous 7777. While iterator does not equal null pointer. No, it doesn't. Values equal 7. Okay, we're gonna do this a bunch of times. Delete node is equal to iterator. We have a special case where the head needs to. We can't delete the head. Okay. I do give up. You're right, Sherwin. Time to go sleep. Also, no more streaming on Twitch. There's too many drop frames. Okay. Good night, everyone. I got to 203 out of, well, according to the 700, but according to the actual list, there's a lot. But I'm gonna do all of them. It might take a while, but I'm going to do all of them. Okay, we're at 3,000, so we're 5% there. I'm gonna keep going though. I'm gonna do it. Tomorrow I'm gonna do all of page 1 and page 2. I'm gonna finish it up. I guarantee. Page 2. Timo. Bro, these guys are league players. Sorry, only 50 a page. I'm like be at 4